What's going on, guys, and welcome back. So in this video we're going to be working on my P28 ECU, and I'm going to be showing you guys exactly how to wire in your PWM boost control kit. I bought this on eBay. It was like 10 bucks. Took a week to get here, but we've got a transistor, we got a diode, 2 resistors, and a MOSFET chip, I believe this guy is. So yeah, we're going to wire all these things in here, and this should allow us to control our boost controller, which is a 3-port. In our case, it's a 3-port boost controller. I'm not sure. I believe you could probably use this to control a 4-port as well. I'm not 100% on that, but I think you can. So a 3-port and a 4-port, I talked about a little bit last time, but basically the difference is with a 4-port, you can actually send pressure to the top of the gate to actually keep it closed, and that'll force you to have a quick spool, whereas with a 3-port, you don't necessarily do that, but what you do is make sure that the pressure isn't constantly bleeding off like a 2-port system like I have right now, which is no electronics involved. So basically we need to send this guy a signal that tells our boost controller what to do and when to open, when to close, and at what frequency to run at, and all that stuff. So that is integrated into Honda Tuning Suite, but we need to put that into the ECU so we can run a wire out of our harness here, out of the jumper harness, and send that to our boost controller, and then probably locally ground the other one, I assume. So we're going to need to figure this out as we go here. I'm going to look up exactly what we need to do. I know we're going to be, I believe, in this area over here, but I'm going to go ahead and take this all apart. This looks different than whatever you have because I put this nice plexiglass cover on here because, I don't know, I think it looks cool to be able to see into the ECU. So I made a plexiglass cover for it, and I know the Hondas have that, and I always thought it looked sweet. So I did that for mine, even though it's just a regular P28. And it is chipped, obviously. It's got my ostrich ribbon cable hanging out of it. I don't want to unplug this if I don't have to, because, you know, I don't want to mess up my socket. And also I have my data logging cable right here. But I'm going to have to pull this thing fully apart. So I'm going to pull this apart, and then I'll pull the bottom apart as well, because the bottom comes off, and then we'll be able to pull out the board and do a little bit of soldering. The tools you're going to need for this is a solder sucker, which is a pretty cool tool. But basically, you load it like this, and then it's got a little hole in the bottom, and when you hit this button, it sucks the solder out by creating a huge vacuum right over it. So you'll heat it up with the soldering iron, and then you'll hit it with this, and you'll be all set. So I think I'm gonna go find a different soldering iron because I have something else that I think it might be more precise, and I'm going to use that instead. And yeah, because we want to be very precise with this. We want to have very good solder joints, and we don't want to create too much heat in the board unnecessarily. And this propane soldering iron I have is good, or butane rather, but it does shoot like a flame out of the side almost, and I don't want to melt any of our components here. So I'm going to go ahead and get a better soldering iron, and I'm going to get started showing you guys what we need to do. Okay, so I think I might have been incorrect before, but with your plugs on this side, on the ECU in this orientation, you should be right here. You'll see, maybe not on camera, but if you're doing this on your own ECU, you'll see D14 and Q29. I wish that the GoPro was good enough, but I don't think that you're going to get a good image there. But we got D14 and Q29. And those are the first ones that we're going to desolder, along with R70 and R71, which are just to the right of these two under this whole set of resistors. So we're going to desolder that with our solder sucker and take the solder out, and then we're going to install our new pieces in those locations. So basically just adding stuff to this ECU. I think we're removing one thing or something like that, but for the most part, just adding on. So D14 and Q29, I'm going to go ahead and desolder that. And I've never done this before, so I'm going to, just do my best. I'm going to go get my nice soldering iron with a fine tip on it, and hopefully we can do a good job at desoldering these guys. So I got my other soldering iron, and I went ahead and sharpened the tip on it. It's a nice point, so I'm very precise with this. And I guess I found the best way to do it is to obviously load the sucker, and then you got to get it. You got to find where it is on the back side here of the ECU, since you have access to the back, and then you got to touch this side while you do the back side. It would be good to have maybe another hand to help, or just a steady hand, because I keep moving it with this, and it's tough to stay on it with this, but I think I'm starting to get the hang of it. So I'll see if I can do one on camera for you. You're probably not going to be able to tell, but I'll show you from this side, and I guess I'll show you from the other side too, and you guys will be able to see what I'm up to. But not terribly hard, but it's also not the easiest thing either. Looks like I got it. So now I can see light through it, so that's all we need to do. And then you empty out your solder sucker here, and you can see that a little bit of solder comes out. Yeah, this thing's doing a really good job. And there's a little bit of residue left on the back, but we'll get that with our solder wicking material after. So here's a shot from this side. We will alright, got that one too. And you don't want to be on the board for too long, because you don't want it to heat up too much, because then you can run into problems, and you don't want any problems. So hopefully you can see I desoldered these 3 other holes that I was told to do, and you can see this MOSFET transistor here. This guy goes right in there like that. So we're going to sit him in there, and now we're going to turn this thing over, and we're going to go ahead and solder him in that location from the bottom. So you can see our 3 legs sticking out here. We'll make sure he's in there good, and we'll solder and then clip off the legs on this guy so that they don't touch anything. So I've got one of those legs on there soldered really well, and I'm just going to straighten it out a little bit, bend one of these legs, get it down as far as we can, and I'm just going to give it a few seconds to cool down. I did heat it up a little bit, getting it all put in there. I don't want to have too much excess heat on the board, and we also don't want to put too much solder, just enough so that it starts to soak in, so we have a good connection, and we don't want to do so much so that we get it to connect all the dots here. We don't want to connect the dots when we're doing this, because then you're going to have circuits that are shorted out together and all kinds of issues like that. So less is more. As long as it soaks in, you're pretty good to go. You don't need to go crazy. So I understand it now. This Q29 that I was talking about is where the MOSFET transistor goes, and that is this guy right here. So those 3 pins, it faces in this direction. Like I said before, with the the plugs going in this way, and this guy right here, and he's facing in this direction. So I soldered those 3 things in there, and so then moving over to here, we're looking at D14, which this is our diode right here. And what a diode does is it lets electricity only flow in one direction. So the side with the stripe on it is our positive side, so it'll only flow from that side to the other side, and it can't flow back the other way. So that just makes sure that electricity has that one-way path. So we're going to go ahead and solder that in. And yeah, all in all, I really don't know what all these components do together and how it all works, but I understand the basics of some of the components and how they work. But I'm going to go ahead and solder this one in too and clip his legs. And you can see, to make it stay in place, I just kind of bent the legs outwards like this. Hopefully you can see that there, these guys. So I'm going to go ahead and solder them in, and we'll move on to the next step. So these guys are our resistors. The one that I installed prior is red brown, and the red brown is a 220 ohm resistor, and that guy is right here or right there. And you're going to install that into R70, And then the other resistor that I have here, which is orange brown, that's a 330 ohm resistor, and that guy is going to go into R71. So yeah, I'm just going to do that. It's pretty easy. You just bend them into place, stick the leads through, bend them out on the other side, and then just quick tap with the soldering iron just so it drinks the solder into both parts, and you can tell it fills in the hole. Oh, you ass. This is our last guy here, this one right here, and this goes in Q20, which is in the upper right hand corner. So you're gonna have to desolder those 3 areas as well, and then stick this Q20 in there, and we're gonna go ahead and flip it over, solder him in nicely to match the other 2 in front of him, because there's 2 more, 1, 2, and this will be our 3rd in the row here, and then we'll have 3 little I guess it's a transistor, and yeah, then we'll be ready to go. Well, you know, all of our legs are all trimmed, and we're ready to use our PWM boost output on pin A11 of this ECU. So that is the plan there, and then we're going to go ahead and see if we can fire up this boost controller like I tried to do before. And I'm going to have to learn the settings, but I got to get it plumbed in. Maybe I'll save that for a different video, or maybe I will do that in this video. I'm not sure yet. I'm gonna have to see how long this is gonna be. But yeah, hopefully you guys are enjoying the process. I definitely am. This is fun. I enjoy soldering very much so. This is very cool for me. So I'm gonna go ahead and solder this last one in, put the ECU back together, and it'll be ready to go back in the car. And then I'll just have the wiring to do as far as putting my boost controller in the car. I'm going to have to plumb that in, so maybe I'll get some vacuum line or show you guys that process as well. Alright guys, so I got the car all pulled in here, and I was reviewing last night my knowledge of, this looks like it's unplugged, okay it's not. I was reviewing my knowledge of boost controllers and exactly what's going on. So essentially, right now, I can show you guys what I have going on. Hopefully it'll all make sense. So I have boost pressure from the turbo that is teed right here, and it goes from the turbo over here to the bottom of the wastegate. And the wastegate inside has a spring. I drew a picture here. There's a spring up top, okay, and there's a diaphragm. And this diaphragm gets pushed up by air getting forced into the bottom section of the wastegate, and that pushes up on that spring. And when that air coming in reaches the set PSI spring that you have here for a spring, which mine I think is 7 or something around there. So the air coming in will overcome this spring at exactly 7 PSI of pressure in here. So when that hits 7 PSI, the spring will collapse, diaphragm will come up, which brings the valve from here, which this is the manifold, my great drawing. This valve actually seals in the manifold, and then when it reaches what it is set to reach here with this spring, the valve will lift up, and it allows the extra pressure in the exhaust manifold to vent out the wastegate dump so you don't overspool your turbo. So I know this isn't a good drawing, but the turbo we have is over here, and this line comes around, and essentially with the 3-port, it's the same thing. We just have this guy, which is teed off, and he's bleeding off over here to my port here, which has a dial on it, which is like a controlled leak here. We have a controlled boost leak coming out of here, and what that does is allows us to overcome this wastegate spring at a later time. So essentially we're running more boost because we're bleeding off extra pressure, and that way this guy right here can operate higher than its rated PSI with the spring here. So with a 3-port, we're going to do pretty much the same thing. We're going to come off the turbo or off the manifold. I've heard manifold might be better because that's what the ECM is actually reading. So that makes sense to me that that would be better. So I think we're going to come off manifold instead of turbo and then come over to the bottom of the wastegate, and that will tee into our 3-port boost controller, which there's a valve in here that works as a pass-through. So it goes here and here, and it seems as though it's always open, which is good. So we have this normally open wastegate right here, and that will push through here, and that line will come out of that same port here that's always open and go to the top of the wastegate. So essentially what we're going to do is keep that manifold pressure at the top and bottom of the wastegate. So what that's going to do is hold that wastegate shut. And when our ECU sees our set PSI or our duty cycle that we're looking for, well, it'll see our set PSI, and we have to set up our activations in the tune. And then what'll happen is it'll command that PWM signal, which is a ground signal that we're going to send from our ECU, and we are going to send this thing switched voltage. So with ignition power and a negative or ground wire run to the ECU on that A11 pin that we just set up our ECU for, we're going to be able to PWM pulse width modulate the ground in order to activate this solenoid at our set activation point on the ECU. So whenever the map sensor reads our set PSI that we're going to activate this solenoid at, he is going to open at a certain amount, which is a set duty cycle, and that is essentially how this is going to work. And we're going to control bleed off pressure out of the system here, out of this vent valve. And what that'll allow is once it reaches the set point, it'll open the valve, allow it to escape. But the thing that's better about it is this valve is held shut, because under normal circumstances, this boost controller, the venting one, the 2-port that I have, it's always a leak. For one, it's always a boost leak, and for two, that valve on the wastegate can be allowed to fluctuate up and down because there's not really anything holding it back other than 7 PSI. So in the meantime, when we're ramping up, that valve can flutter. So it'll be good to have it all sealed off here and make sure that we have no valve opening. So hopefully it allows us to come into boost quicker, and that is where you hear quick spool, and hopefully it does have us spooling the turbo quicker. It'll keep the gate shut for longer. So that is the goal. I just need to get this wired up, and I'll show you guys exactly how I'm going to do it once I figure out how I'm going to do it. But hopefully you guys understand it better. I know my diagram is very bad, but hopefully the explanation made up for it. Alright guys, so I've been at this for the better part of the night here, but I think that I do have it set up like I want it. So you can see, just for now at least, I decided I'm going to go directly off of the turbo and just keep it the way that it was. And I go into our little T here, and there's a direction. I don't know if that actually matters, but we'll go into our little T here. And I might just get a regular vacuum T to eliminate this thing too. I don't know what the heck this thing does. It came with the boost controller. I assume it's just a normal T. So we're going this way, and we're going into the bottom of the gate, and then we also tee that off into the bottom part of our 3-port boost controller, right into the bottom here, and the vent that is connected to is right here, and that guy is sent to the top of the gate. And this port right here is just vented, and that's normally closed. And so we have our 2 wires here. This one is run from the ECU from A11, and then I ran through the firewall, and I set up with a little pigtail assembly here that I'm going to go ahead and connect all the wires to. But first I want to do a little math here, and I want to get the resistance of this guy and find out with based on voltage, say 14 volts, what kind of amperage is this guy actually going to pull, because we're going to make sure he's not going to pull over 3 amps, because that will potentially damage our ECU. So we got to check that out. And I have right here, which is what should be switched power. This guy right here comes from one of the plugs back here. It was either for evap related stuff or something that I unplugged, something that I don't have, so I assume it's evap or something like that that I deleted. but I'm just going to go ahead and splice into here back there, if you can see that. And yeah, this guy's just spliced in there. 12 volt switch power running to there, and then we have our ECU PWM ground. And so yeah, like I said, I'm just going to take my multimeter and I'm going to measure the resistance on this line. So I did a few calculations and we ended up coming out to 23.4 ohms. So if we take the max that we'd be at is 14 volts while charging, divided by 23.4 ohms, which, you know, if you know Ohm's law, to get I, which is our amperage, which is our current flow, you need to take voltage divided by resistance. This puts us at 0.60 amps, which is nice and low, nowhere near the 3 amps that we could potentially do from our ECU there. So we should be all set. Last thing is I'd like to meter it, but I think we'll be okay. I think it's going to work fine. I can't see it pulling any more than 3 amps. So I think we're just going to send it. If it blows up the ECU, it blows up. It is what it is. But I don't think that's going to happen. So I'm going to hook up these wires and go ahead and get everything all soldered. And then the next thing that we're going to have to do is test it. So that's going to probably be for a later video. And I'll show you guys how to configure it in HTS and how to tune it. So that's going to be it for this video, guys. I'm going to sign off for now. Hopefully you guys enjoyed this setting up boost controller within the ECU and in the engine bay here, because we pretty much got it all set up. Just got to actually figure out how to set it up in the tuning software and figure out how to actually put it into practice. So it's pretty cool. I'm excited about this. Hopefully the diagram helped and you guys understand what's going on. And if not, definitely let me know if you got questions. But I appreciate you guys watching. And consider subscribing if you're enjoying the content, because there's definitely more to come. This car is far from done. Still got lots of paint work to do, lots of other stuff to do, but yeah, this car will never be done, to be honest. But it is what it is, and if you guys stick with me, you'll see the whole process. So follow me on Instagram. I'll put the link in the description. It's That Accord Guy. If you guys want to see some random updates that I have occasionally here and there. But yeah, I won't drag it out any further. Peace out.